Gas chromatography, separating the elements of science. Welcome to our educational video on gas chromatography, a powerful analytical technique that has revolutionized scientific research and various industries. In this video, we will explore the history, real-life applications, instrumentation, working procedure, and necessary precautions associated with gas chromatography. Gas chromatography was first conceived in the 1940s by a Nobel Prize-winning scientist named Archer John Porter Martin, together with Richard L.M. Singh. This revolutionary technique was developed to separate complex mixtures into individual components using gas as the mobile phase and a stationary phase. Gas chromatography plays a vital role in a multitude of real-life applications. Environmental analysis, detecting pollutants in air and water. Pharmaceutical industry, ensuring the purity and potency of drugs. Petrochemical industry, analyzing hydrocarbons in petroleum products. Food and beverage, identifying flavor compounds and ensuring food safety. Forensics, analyzing volatile compounds in crime scene investigations. Instrumentation. The gas chromatography system consists of several essential components. Sample injection port, where the sample is introduced into the system. Carrier gas supply, provides the mobile phase to carry the sample through the column. Chromatographic column, the heart of the system, where separation of compounds occurs. Detector, measures the amount of each compound as it exits the column. Data acquisition system, records and processes the detector signals for analysis. Sample requirements. To ensure accurate results, proper sample preparation is essential in gas chromatography. The sample must be in the gaseous or vaporized state for injection. If the sample is in a liquid or solid state, it needs to be volatilized before injection. This can be achieved through techniques such as headspace sampling or derivatization. Working procedure. Here's a step-by-step working procedure of gas chromatography. Step 1. Sample injection. The sample is introduced into the injector and vaporized. Step 2. Carrier gas flow. The carrier gas pushes the vaporized sample into the chromatographic column. Step 3. Separation. Compounds interact with the stationary phase in the column, causing them to separate based on their properties. Step 4. Detection. As compounds exit the column, they pass through the detector, generating signals that are recorded. Step 5. Data analysis. The computer processes the signals, creating a chromatogram, which reveals the composition and quantity of each compound. Precautions. To ensure accurate and reliable results, certain precautions should be taken. Column selection. Choose the appropriate column type for specific applications. Temperature control. Maintain a constant temperature to avoid undesirable effects. Sample purity. Ensure samples are pure and free from contaminants. Calibration. Regularly calibrate the instrument using standard compounds. Maintenance. Regularly maintain and clean the system for optimal performance. gas chromatography has proven to be an indispensable tool in modern science, providing valuable insights into the composition of complex mixtures. Its applications continue to expand, influencing industries and research fields worldwide. By understanding the principles, instrumentation, and precautions, scientists can make the most of this powerful technique to unlock the secrets hidden within the elements of science. If you have any questions or want to learn more about specific topics, please leave a comment below, and we'll be happy to assist you. Remember, the world of science is full of wonders, and gas chromatography is just one of the many tools that continue to shape our understanding of the universe. If you enjoyed this video, don't forget to like and subscribe to our channel to stay updated with more exciting content on science, technology, and innovation. Thank you for joining us on this journey through the fascinating world of gas chromatography. We hope you've gained a deeper understanding of this powerful analytical technique and its numerous real-life applications. Until next time, keep exploring, keep learning, and keep pushing the boundaries of knowledge. Stay curious, and see you in the next video.